Greetings, everyone. I'm Stephen Hamilton, KJ5HY, and Chuck Suslowicz, KD2RQS, also helped with this project of graphing Inphase and Quadrature, or IQ, data from an SDR into 3D space. We began by using the Visualization Toolkit, VTK, and Python to read the IQ data and convert it to points in 3D space by putting the I and the Q on the X and Y axis, and then creating a time axis in the Z direction. So first I'm going to show you, this is the script that we have, and thanks to Chuck, he helped me create the arguments here so that it's a little more user-friendly, because before it would just crash if you didn't put a file in. So now we know here's all the arguments you can do. We had to add a Z-scale because we found that we were playing with that a lot to try to get this to look right, and also the sample rate, because sometimes you'll sample at different rates and you want to make sure you get that correct as well. We also added this idea of adding I and Q on the X and Y planes, which I'll show that in a minute. Okay, so I'm going to show you one of the first ones that we did was this FM low 2X. So basically, I took a handheld transceiver in the RTL SDR and just listened to that frequency, recorded the IQ data, and transmitted 2 times. So after I did that, we'd run it through the program. It does a few sanity checks to make sure that it's actually getting the I and Q, and then it creates a VTK file that I can use in Paraview. So now I'm going to switch over to Paraview. We'll be done with the Python now. There's Paraview. I've already got some of these preloaded just for the sake of time, but I'm going to load this FM low 2X. You can see the one that I just converted right now. So we looked at this, and this was really, really exciting when we first saw it, because now we can see visually that there were 2 distinct transmissions. We weren't too happy about how messy it was. There's also a weird break in it as well, which I'm really not sure what caused that. But the good thing is we did prove that we were actually getting the IQ data and plotting it, and it seems to start to make sense. So after that, I did another transmission, and this one I was real close to the RTL SDR, and you could see some really weird artifacts that happen here. It turns it into 2 boxes. So the problem with this is I think it was clipping is what probably makes the most sense. So I basically were maxing out the I and Q values, and so just totally clipped the transmission. So this was good because we saw a difference as you get a stronger signal. That's why the other one was called low, because it was a lower signal. I actually had to take the antenna off to keep it from over modulating like this. Okay. So the next thing is we had to use a generated IQ data from GNU Radio. So this is QAM 16, and this is perfect. Like this shows that we're doing this correctly. I just generated inside of GNU Radio, recorded it straight to a file sync, and then ran it through our script. So after that, I said, well, maybe we need to check out a different SDR. So we moved to a Midwest Microwave Solutions SDR, and that one we did some FM voice. This looks a lot cleaner. You can really see the signal here, which was pretty exciting. You could see it looks like FM, kind of what FM you would expect to look like. The frequency looks like it's changing right in here. So that was good. It's good to see. So that got us excited. So we decided to say, well, what other types of modulations would look neat? So we went up and did RIDI, which I had to use the Noelec, and it was a transverter that we used to bring up the frequency so the SDR could receive it. And this worked out really nicely. This was real pleasing to see, because now we can really see that modulation. It was very clean. This was done with a FL Digi and the Electromagnetic KX3, and then just recorded with that Midwest Microwave Solution. So this was real exciting to see when we did that. Next one we did was QPSK. You can really see the amplitudes changing here, real nice on this one. And so this one I'm going to show, since this one was probably one of the neatest ones that we got so far, I'm going to show you adding those other components. So if we go to this next one, this is probably the nicest looking one I have. So I've added that I and Q on the side so you can see how that's graphed. I've also converted them to spheres. We found that looks kind of, it gives you a little more feel of what's going on. That's like textbook quality. So this was real exciting to see that we got this. So this is a real generated signal that we recorded. Obviously we were close to the SDR, but it didn't overmodulate and it just came out as a beautiful signal. So that's our project, and I guess we'll move on to the question section.